Hi everyone, this is Dr. Hess. We're going to use some more 3-column notes and talk about another concept. We're going to talk about normal distribution and z-scores and probability using z-scores in the standard normal distribution. Here's a specific problem that we're going to be able to solve by the end of the video, but we'll come back to it in a minute. First, we're going to talk about some concepts you need to understand before you can solve this type of problem. First, you need to know what is the normal distribution. So if you have a set of data, the idea is that the normal distribution has a mean of 0 and a standard deviation of 1. So if you're going to look at a histogram, you want a histogram that has a bell-shaped curve, and when you make it into a smooth curve, the area under the curve is 1 or 100%. So the probability, when you're talking about the standard normal curve, is going to be somewhere between 0 and 1 because you're looking at 0 and 100%. Data that is normally distributed would be things like heights, blood pressure, IQ scores. The idea is that there's a typical average and there's a little bit high, there's some higher and there's some lower. And 100% of the data is going to fall within the ranges that we see in the normal curve. So when we're doing these types of calculations, we're going to need to use a z-number or a z-score. Those two terms are interchangeable. A z-number is kind of like a standard deviation. It tells you how many steps away from the mean you're taking left or right. It's kind of like a number line at the bottom of the standard normal curve. Data that does not have a mean of 0 and does not have a standard deviation of 1 can be rescaled so that you can compare it to standard normal distributions. I'm going to show you a picture to help you understand. So this is a standard normal app that we're going to be using to make calculations. So notice how it's a smooth curve. We've got this number line on the bottom. These are our z-scores, also standard deviation. So here's our mean of 0. Here's one standard deviation out to the right, one standard deviation to the left. And this one would be a z-score of 1, a z-score of -1. And we're going to be using this app a lot. You can start by, we can find an area or a value based on what we want. We can tell it that we have a mean of 0 and a standard deviation of 1 because it's a standard normal curve. And then these values right here are what are called our different z-scores based on the area. The black shaded area is the area. So if we were to shade in this whole thing, it would be 100%. And right now we just have the top right portion shaded. And so that's an area of 0.025. Multiply that by 100, that's 2.5%. So just a little portion. If we were to look at below, that's 0.975 or 97.5%. And if we were going to click on between, it would be looking at between these two z-scores, the -1.96 and 1.96. It's saying this black area shaded is 0.95 or 95% of the bell curve is shaded right there. So hold on to that for a minute and we'll come back to it. This is a big concept, so we'll work a lot with it. Okay, so now that we understand what the picture looks like, we're going to think about what this means and what we're going to do with it. So in the problem above, we're told that there's a mean of 70.9 and a standard deviation of 8.5. It's normally distributed, so that means we can rescale it and use our standard normal. And so that means we need to use a specific formula. So we're going to use our z-number or z-score formula. So the formula, write this down on your formula sheet, is z equals x minus the mean over the standard deviation. So that fancy looking m is called mu, that's the mean. The O with a tail is called sigma, that's our standard deviation. And so we're going to need to read the problem and look for a mean and a standard deviation. So always take a few minutes to read the problem and make sure you understand. So the problem right here said the mean is 70.9, so we know what this value is. And it tells us that we have a standard deviation of 8.5, so now we have this value. And so now we need to figure out what is this x, and they gave us two. They gave us an x of 90 and an x of 50. So we're going to solve this problem twice because there's two values that we're looking to find. So here we see we have our x is 90 and 50, our mean is 70.9, and our standard deviation is 8.5. So now we're going to plug that into the formula. So when we're using the x is 90, we're going to have 90 minus 70.9 all over 8.5. You can definitely use Desmos to solve this. This is a great way to make sure that you don't accidentally mess up the order of operations by doing this on your phone. So go ahead and pull up Desmos.com. It's a free online graphing calculator. So you'll type in 90 minus 70.9, and if you put that in parentheses and then divide it by 8.5, there's your z-score of 2.247. And so now you can take that over and write that down as your answer. And now we can keep going on. So in this problem, our z-score was 2.247. When we're asked to round to 2 decimal places, because there's a 7 at the end, the 7 would bump the 4 up to a 5. So here's a problem I'd like you to try on your own. So pause it, read it, and try it on your own, and then come back and see how you did. So here's our answer. So in this case, we were looking at an x of 50. And so the only difference between last time and this time is we put a 50 here. Everything else is the same. Notice our answer is negative because 50 minus 70.9 was negative. And so if we were looking at our bell curve, the z-score that we just found would be about right here. And the z-score that we found last time it will be on the other side. Okay, now we're going to talk about probability and normal distributions. Now that we know how to find z-scores, we can find the probability between or above or below. So as a reminder, probability with the normal distribution is going to be between 0 and 1, which is the same as between 0 and 100%. You can't have negative percents, and you can't have anything bigger than 100%. So it's never greater than 1, and it's never negative. If your values are not z-scores, then before you can solve the problem, you need to convert it. So in the problem we have up above, we don't have z-values, but we have a normal distribution. So we have to convert them to a z-score like we just did. So first we need to convert x is 50 and x of 90 to z-scores, which we just did. And so now we need to open up the normal probability app. So the question we're looking at says find the probability of x being between 50 and 90. So we found our z-values, or z-scores of negative 2.458 and positive 2.247. We're going to open up the Z app and plug those in. If you go to the comments in this video, the description of the video, you can find the app. All right, so here's our app. So we need to find between negative 2.458 and 2.247. And we want the area between it because that's what the problem asked. And so once we've clicked the first box and the area between, we're going to click recalculate. And what it's telling us is if we have a z-value of negative 2.4 and a z-value of 2.2, the percent of the curve that's shaded is about 98%. So here I have the steps listed just in case you need those as a refresher. I'm going to show you 3 more problems. What's the probability that x is greater than 50? What's the probability that x is less than 50? And what's the probability that x is outside of 50 and 90? So remember, we converted 50 to a z-score, and 50 as a z-score is that negative 2.4, and 90 as a z-score is 2.247. So we're going to use these in our normal probability app. So go back to that probability app with me and let's talk. Okay, so as a reminder, our first question is what's the probability that x is greater than 50? Well, 50 turned into a z-score of negative 2.458. So we want greater or above, and it's negative 2.458. And then we want the area or probability. So you'll click recalculate. And what it's saying is here's negative 2.458, and everything to the right of it is about 0.993 or 99%. The next question is find the probability that x is less than 50. Now remember that 50 changed into a z-score of negative 2.458. So less than would be below. We'll click on that recalculate it, and notice how it's just a tiny portion here. So it's 0.007. And then the last question was find the probability of x being outside of 50 and 90. So here's the outside option. And our 50 as a z-score turned into negative 2.458. And our 90 as a z-score turned into 2.247. And when you click on recalculate, outside gives you those little tiny tail areas, which ends up being 0.0193 or 1.93%. So you might need to come back and watch this again. This is new, but once you've seen it a few times, it comes a little easier. All right, so those were the problems we just solved. And as a reminder, those are the answers that we just got. So if you're having any issues, just go back and watch this portion again. So in summary, we talked about the standard normal curve. We talked about what a z-score or a z-number is. The formula to convert something that's not a z-score into a z-score. If you have height data or heart rate data and you need to change it so it has a mean of 0 and a standard deviation 1. We talked about how to use the normal probability app and how to find probabilities using that. So I'm going to give you an extension. So find the probability of x being greater than 90. Find the probability of x being less than 90. Use that same standard deviation and the same mean that we used before. So you might need to back up the video. Pause it, try it, and come and check your answer. So first you had to convert 90 to a z-score. Then the above area was about 1.23%. And the below area was 98.77%. Thanks for watching. Let me know if you have any questions.